Hello everybody, welcome to Sane Game Studios. I'm Sane, I'm an amateur game developer. Today on Gamemaker for Beginners, we're going to be doing our final video on collision functions. So we're going to be looking at collisions without a mask. And this is where you take the function and you feed it an area, and then you feed it either a point for some of these functions or another area, and then it'll tell you whether that point exists inside of the given area or whether those areas overlap, and then more interestingly, how much they overlap, which is something that's actually really cool. It's going to be built into this. There are 6 functions that are included in this, but I'm only going to go over 2 of them for the main reason that they all work the same. The only difference is the shape. So the first ones we're going to be looking at are going to be point and triangle, point and circle, and point and rectangle. Like I said, the only difference between these is the shape, so I'm only going to focus on one of them, and then if you were to use the other one, like I said, the only difference is going to be the shape that you create with the function. Of these 3, the one that I decided to do is point and triangle for a very specific reason. So the reason why I'm using point and triangle is because a triangle is a really good shape for creating a cone of view for line of sight. So in my various projects, I have used multiple methods for line of sight. I've used a platformer where I just use collision line to see whether or not the player exists at the eye level of the enemy in a straight line from there. I've also just done like a top-down game where I just use a collision circle. So I just use proximity detection. If you got so close to the enemy, the enemy would detect you. But I've used point and triangle with enemies as well, where I will create a triangle based on the direction that they're facing and create a cone of a line of sight, and then I will use that for my enemy line of sight. And that is the main reason why we're going to be using point and triangle for the purpose of this tutorial, is just so that we can show how that works. So what I'm actually going to do to show this off is I'm going to go into my room here and I'm going to delete 2 of these walls, and I'm going to have this wall detect the player. So I'm actually only going to have the wall be looking left, but then I'll also be doing a brief explanation on how you can get it to look in any direction based on the direction that the enemy is facing. So to quickly demonstrate how exactly point and triangle works, I am going to just pull up my Paint application here. And we are going to create a couple lines. Well, actually, first, let's set Alright, so right here, that will be our enemy. I guess I'm building this looking to the right, but it will work the same either way. And we are going to create a triangle loosely that looks like so. That's going to be originating from the enemy and protruding outwards. And it will create what I'm going to refer to as a line of sight. So the next thing we're going to have is we're going to have the player here. And as you can see, the player is currently not inside of the line of sight. But then if I were to take this player and move it over here, then we will be inside of the area of the line of sight. So then I want this triangle to return true for being inside of it. So to do this, I'm going to go into my O wall here. Because like I said, I want the wall to detect the player. And I'm going to add the step event. And the first thing I'm going to do is I'm going to create a handful of local variables. I'm going to go var x2 y2 x3 and y3. And actually, I'm going to create another local variable. And I'm going to call it dir for direction. And I'm just going to have it equal 180. Because if you remember from my previous tutorials, if you have seen them, if I have a circle and I have a point in the middle, this right here is 0 degrees. And then it wraps around this way. So if I were to create more lines, this one right here is 90 degrees. And this one over here is 180 degrees. So I want to use 180 because I want my triangle to be going to the left. Because in my room, my player already exists to the left of my wall. So it's just going to make things much, much easier. So for my x coordinates that I'm going to be using to build the triangle, I'm going to be using my length dir functions. I'm going to go x, y, x, y. And the length, I'm going to say the length's going to be 100. The direction is going to be dir plus, say, 15. 100 dir plus 15. And then 100 dir minus 15. So what that's going to do is it's actually going to create a couple points that are going to roughly be like that. And it's going to create this cone. So the next thing I'm going to do is I'm actually going to go to the create event. Create a boolean called found. Then I'm going to say that found equals point in triangle. So this is going to take a handful of arguments. The first thing it's going to ask for is the point that you want to see is in the triangle. For this situation, I want to use my player's point. So I'm going to use oplayer.x and oplayer.y. And then once I have my x and y of the point that I want to look for, I want to create my triangle. So my origin of the triangle is going to be my current x and y. My next points I have created up here using length dir x and length dir y. So I'm going to go x2 and y2. And then my final point I've created here. So I'm going to go x3 and y3. So with this done, this is going to create the triangle and find the player. So I'm going to copy these And I am going to go add open event, draw. First thing I'm going to do is draw self. Next, I'm going to bring in these variables because I'm going to need them for drawing the triangle in the draw event so we can actually see it. And then we go draw triangle, go x, y, x2, y2, x3, y3, outline true. Because I only want an outline, I don't want a filled triangle. And then if found, draw text, x, y plus 60, found you. So, like I said, I am using my length dir x and length dir y to create the points for my triangle. And then I am using those to create a triangle using the wall's x and y position as the origin. In most situations, I would be doing this exact thing. The only difference is I wouldn't be doing it in a wall. I would be doing this in a enemy. So if I run this now, I know what I did wrong. See, it's going way off up there. The reason why it's doing that is because I did not specify where to draw this from. So what I'm actually going to do is I'm just going to go x plus, y plus, x plus, y plus. And the reason I have to do this is because unless I am adding these lengths to my current position, it is going to use the 0, 0 position for that, which is going to be off the corner of the screen. Update it here as well. Alright, see, I have my triangle. It's actually quite small. So I'm going to change this to say 250. There we go. I have a good sized triangle. And if I enter it, it says found you because the wall has found me. The only real catch that exists from this is the fact that it's a maskless collision. I am creating a collision mask in the shape of a triangle, and then I am using the X and Y position of my player to see whether or not I am in it. So as you can see right here, I am inside the triangle with my collision mask, but the enemy has not found me. And the reason is because my X and Y position of the player is going to be the origin point of the sprite. So if I move up, see, it found me. So how would I do this dynamically? So like if the enemy was moving to the left, it would be like this. But if the enemy was moving downwards, it would be over here. If the enemy was moving to the right, then the triangle would be over here. If the enemy was moving upwards, it would be over here. How do I do that? And that is very simple. That is where this comes into play. So instead of creating a local variable and setting it to dir, a local variable and setting it to 180, I would instead use the direction that the enemy is facing. So let's create a new variable called dir, and let's delete this, and let's delete this. And now I'm going to say if keyboard check pressed VK up dar plus equals 90. And then let's do this again. But instead of up, let's do down. And dir minus equals 90. So now I can change the direction with my arrow keys, and we can rotate this triangle around the enemy. So there it is, facing to the right. But if I hit the up key, it faces upwards. If I hit the up key again, to the left, down. And now I'm able to rotate this point here, and I can use that to create a dynamic field of view for my enemy that will always be facing whichever way the enemy is facing. The only difference that instead of controlling it with my keys, I instead would allow the enemy code to control it during wander, so that the direction always faces the same direction that you are drawing the sprite, so that you have a visual cue on the player side for what direction the enemy is looking, and then also have that tie into its line of sight to make it so that the enemy is able to visually spot the player and then react accordingly, whether you want them to act startled and run away, or you want them to charge after the player, or whatever. This is a really good way to do this. And that's really the all I really need to do for the point in functions. Like I said, there are others. There's also point in circle, as well as point in rectangle. And they operate the exact same way. The only difference is this one creates a circle using a radius, and then this one creates a rectangle. So the next ones we're going to be looking at is going to be, there's rectangle in circle, rectangle in rectangle, and rectangle in triangle. Again, these are going to all work the same way. The only difference is the shape that you are using here. And then they work very similar to the point in situation with a couple key differences. One, you're going to have a rectangle that you create, so you can almost create like a false collision mask for like the player in this situation, which is what we're going to do. We're going to do a couple things differently though. So I'm actually going to change this 15 to a 25. So we're going to have a wider line of sight. Let's update that here as well while I'm doing that. So we're going to be doing rectangle in triangle, and that is just so I can build on what I've already shown you with point in triangle. And personally, I find that rectangle and triangle is going to be the one with the most use case. So to do that, we are actually going to create a couple more local variables. I'm going to go var rx. I'm going to go var rx1, and it is going to equal oplayer.bboxleft. And actually, this is not something I've done before, so I'm kind of just rolling the dice here and hoping this works the way that I want it. So var ry1 is going to equal oplayer.bboxtop. rx2 is going to equal oplayer.bboxright. and ry2 is going to equal oPlayer dot bbox bottom. And then I am actually going to cut all this away because I want to do this in the end step event for this situation. And the only reason why I'm doing it in the end step is because I'm going to be using my my player's bbox variables to figure out where the square is. So I want my player to have finished all of its movement by the time that I actually do this. If you don't know what the bbox are, that's fine. I actually created a tutorial on instance variables that is going to explain all of these things. I'll put a link to that in the description down below. I'm also going back to my create event, and I'm going to say that found now equals 0. And now I'm going to say that found equals rectangle in triangle. So this thing actually takes like quite a few arguments. So the first thing it's going to ask for is the top left corner of where the rectangle is. And then it's going to want the bottom right corner of where the rectangle is. And then it's going to need the X and Y position of all 3 points of the triangle. And I have figured all that information out right here. So I can just punch all these things into this function, and it should. The only part I'm actually skeptical about is whether or not this works the way that I want it to. So SX1, that's going to be RX1, RY1, RX2, RY2, XY, X2, Y2, X3, Y3. Oh man. And just to be safe, I'm also going to be putting all this in the draw end event. I shouldn't need to do this because the step event's going to happen before the draw event. And then the draw end event is generally something that you want to avoid because it's going to affect the depth of the things that are drawn. Something drawn in the draw end event is going to draw in front of everything else, regardless of the depth order that you want. So the next thing I want to draw is I want to draw my rectangle. And I'm going to be drawing this at RX1, RX2, or Y1, RX2, RY2, outline, true. And here I want to say if found does not equal 0, and I'm going to be explaining that in a few minutes here. So if found equals 1, and if found equals 2. So if found equals 0, then we are not going to draw any of this. If found equals 1, we're going to say found you, and if found equals 2, we're going to say really found you. So let's take a look at what this is going to look like, because I am honestly curious. So as you can see, I have my triangle and I have a box drawn around my player. So my bbox stuff is working the way that I wanted. So if I just touch it, Oh, really found you. That is not... Okay. So as you can see, it's working absolutely great. I got a little bit turned around on how it works, and I'm going to explain exactly how I got turned around on that. So to explain that, I'm going to go back to my paint function here. And I am going to erase all this. Okay, so what's happening is I have a triangle. Actually, more accurately, I have three, essentially, is what we're going to be looking at here. Because we're going to be looking at the different circumstances and how this all works. So, if my rectangle is here, found is going to equal 0, because at no point does the rectangle and the triangle overlap with each other. So let's say that instead, my rectangle is here. Then found is going to equal 2, because it is overlapping, but not completely encompassing. So the rectangle does overlap with the triangle, but the rectangle does not exist solely inside of the triangle. So then found equals 2. So this is the 0, and this is the 2. So then the final one is, let's say that my rectangle is here. So the entirety of the rectangle is inside of the triangle. That's going to return a 1. So how is this useful? How is this something that is particularly good to have? And that's a really good question, and I think there's quite a few answers for this. Actually, the limit to the amount of answers for this question is really based solely on your imagination. But the best example that I can come up with is, you know, those old school Zelda games. More specifically, you're looking at like the Game Boy ones where you have like the Rock's Feather, where you're able to jump, and you're able to jump over like holes and gaps and stuff. And then if you land partially on the gap and then partially on the ground, then Link does this weird like dashing animation where it looks like he's trying to run out of the gap, and then depending on how far into the gap you are, or, whether or not you are pressing the right directional button towards the actual ground, is going to determine whether he makes it onto solid land or whether he falls into the gap. This is a great way to do that, because this is actually going to work the exact same if you have rectangles. So this is exactly how rectangles are, right? So like the point in rectangle works the exact same way. So let's say you have this rectangle and you have this rectangle. So this rectangle is your gap, and this is where the player landed. That is a safe landing. The guy made it, like Link made it all the way onto solid ground. You don't need to figure out whether or not he has fallen. So let's say this is your gap. And let's say this is where Link landed. Obviously, he landed completely on the gap. You don't need to figure out whether or not he's going to fall. He is going to fall, period. But let's say this is your gap. And That's how Link landed in that situation. So you were partially on the gap, partially not on the gap. And this is where you would see whether or not the player is holding the button to try to dash their way off of the ledge onto solid ground, or whether the gap is going to suck the player into the hole and fall. So this is where these functions come so in handy. So like if I have my brush here, this right here, where you have completely missed the gap and you have made the jump no problem, this is a 0. This right here, where you are completely falling into the gap, undeniably, you have not made this jump in any way, shape, or form, that is a 1. Now this one right here, where you have half landed on solid ground and half landed in this hole, and you need to figure out whether or not the player can run onto solid ground or whether they're going to get sucked into the hole and fall, that's a 2. So this is probably the best use case I can think of for a standard example of how to implement this. And these are honestly very handy functions. So actually, it would make more sense here if I change this to be like that. And then actually, let's get rid of these. And let's set dart equal 180. So if I were to just touch this a little bit, see? Found you. Beautiful. It's exactly what I want. This is 0. Hasn't been found at all. Partial overlap. Found you. Completely encompassing. Really found you. There's a lot that you can do with these type of functions, and this is the only collision function that I personally have ever found that doesn't return either an ID or a true or false. If you wanted to treat this as a true or false, you would just very simply do what I've done here. If found does not equal 0. If it is not 0, that means that it is colliding in some way, shape, or form. Then if you want to get further into how much it's colliding, that is where 1 and 2 come into play. Like I said earlier, there is also rectangle and rectangle, which I demonstrated how that works in my Paint application. And there's also rectangle in circle. And these are going to work the exact same way as rectangle and triangle. Like I said, the only difference is the shape that you're using. So I'm not going to go over them independently. They work the same. But that's all that I have for you guys today. This is my last video where I'm going over all of the collision functions. I have a lot more videos coming out about just functions as a whole, trying to just educate you guys on all the basic functions that are going to exist out there. I actually have a lot of videos that I'm currently working on building, and I'm really excited for them to be trickling out over the next few weeks. Stay tuned for next week, where I'm going to be getting into custom functions, where you can write your own functions and why you would write your own functions and what these things can do. If you have any questions about what I have done today, you can go ahead and comment those down below. I will absolutely go out of my way to try to help you out and get things working in your project the way that you would like them to be working, or help broaden your knowledge. It's something that I really do enjoy doing. Every single person that has reached out to me looking for help has received help, whether I'm able to just help them with a quick comment in the YouTube section, or whether we start emailing back and forth and you start showing me your code and I go over it with you, or I've even made videos to show people and go more in depth into what it is that they are struggling with. So yeah, don't be shy to reach out to me and ask for help. It is something that I really do enjoy doing, and it's one of the main reasons why I started this channel. If you have any tutorial requests, like I said, I have a lot of requests that I'm currently working through, so I have a bit of a backlog, but I will always make community requested tutorials before I make the ones that I personally want to make. So if you have any requests, absolutely request tutorials, and you will get added to the list of viewer requested tutorials that I am currently working on. Other than that, just please like, comment, and subscribe. It really helps me out a lot. I hope you guys are having a good one. Peace out.